Hello everyone and welcome on Explored AI, the YouTube channel where we talk about cloud, data and of course AI. I am Lionel, an AI solution architect, and I'm going to talk a lot in this channel about everything turning around those systems. Today we are diving in one of the most known and most practical use case of AI, talking about building your own local RAG. RAG stands for Retrieval-Augmented Generation, which is one of the architecture of the AI that gives you the ability to question your personal data. Because as we all know, as we are using our chatbot like ChatGPT and Claude and many others, it is not able to answer to our personal data. For example, if I have many files that I want AI to help me on, I am obliged at every time to upload them to have some kind of information, and sometimes I don't want to do so. So having a solution, having a system that gives me the ability to question it, to query it, and to use the power of the AI on my personal document is somehow so much interesting. So we are going to dive deep in why this is important, which kind of issues it is addressing, and how to build it. So we're going to talk about architecture, we're going to talk about why, we're going to talk about many tools that it used to build such of systems, and of course we're going to dive deep and to put our hands in all those kind of stuff and to implement it. So I'm just happy to be with you in this video. Let's go. As you can see in this architecture, many AI systems used to work like this. We have a central system here that receives the query from the user, then call the model. You just have to encapsulate it in an internal prompt, and we're going to have internal prompt with the user query. Then we're going to call the model that we have. After that, we just render the system, and of course you can have some kind of tool calls like internet or other kind of other system, but it basically works like this. But the issue with this is that we are not able to query our own system. If we want to query our own data, we are obliged every time to send some kind of personal data here, so we upload it in every kind of query that we are going to do. And what the system going to do is that it just take this internal prompt plus the user query with personal data, and it send it to the large language model, and then we have an answer. So that is difficult. I won't say difficult, but it is not really optimized. It's going to be better if we have a system that is completely grounded to our personal information. So the RAG architecture is one which is there to answer to this issue. As you can see here, there are already many differences. Many differences. We are linked to a database, and that database contains our personal information. So, as I was saying before, the internal system cannot have our personal information unless we send it in every request. But what we are trying to do here is that we are going to link the system to an external source, which in fact here is a database that we used to call we used to take vector database. You also have graph databases, but here we're going to talk with a vector database because we have the possibility to make some kind of similarity research so that we can retrieve only information that are relevant to our current query. So what it's done is that we just send our system, our personal information to the system, and it's going to ingest them and store them in our internal vector database. So tomorrow, when the user is going to make his query, what we are going to do is that we first retrieve in our vector database only the information that we need. We are not going to take everything, but only those informations that are related to the user query are going to be used for the final query to the large language model. So now the structure is completely different. We have internal prompt, we have user query, and we have a context that is the set of all the related information from our personal data. And then we are sure that the large language model is more able to answer with better information and completely related to our personal situations. So later we are going to deep dive in what are the tools, what is the stack that we are going to use to build this system. Here is the technical stack that we're going to use to implement our RAG system. The first one is FastAPI, which is a Python API framework which helps us to build easily and efficient API. It's going to take the query from the users so that our system can work efficiently. We are going to use a LangChain, which is a Python AI framework, which helps us to build some kind of workflow, simple AI agent, and it's going to wrap all those things. The vector database is going to be ChromaDB, which is an open source vector database and very easy to use. And to have our AI model locally, we're going to use Ollama, which is local AI model management, and it works pretty easily and pretty fine. So as you can see, we already have our RAG system with the technology that we are going to use here. Here we have the user which sends his query to the system, and we have FastAPI which is in front and which is going to intercept the HTTP request. After that, it's going to send it to our Python application, which firstly going to retrieve the relevant document, and these documents are just chosen using similarity research based on the user query. So we are not going to take all those personal data, but we are just going to take what we are interested with. It can be 1, 2, 3, 4, or maybe more documents, but generally used to just say 4, but it depends on you. And we are going to have our internal prompt plus the user query and plus the context, and the context here is just all the relevant data that we have, and then we send it to our model, whether it's going to be Mistral AI, GPT OSS, which is an open source model, Llama, or any other that you want. And just to precise, Ollama just accept open source model. After that, we are sure that we are going to build an application which we are going to have an answer that is more efficient and which contains personal information about the user. And when saying here personal information, is not just about the user, but much more information than the general information which are contained in models that are trained and released. So you can find our project here, which is named RAG 101. So that is a very simple Python project where you can see requirements, the txt with every kind of dependencies that we're going to need. We have FastAPI for our API framework part. We have LangChain we're going to use help us to have this framework which will help us to query easily our large language model, also to read our files, to process them, and every kind of information. So here is the code. So the first thing that we have is that, as we know before, when the user makes his query, what do we have? We have the API, and for the API we do have ingest. Ingest is the endpoint that we are going to use to ingest files in our system, because as I was saying before, when you have those informations, of course you have to ingest them. You can automate it, you can use an API, but first of all these information should come here and be ingested and stored in the database, so that the next time we're going to query the system, we can come and use them to query our large language model. So here is the endpoint that you can see. We just received information here, and here is the query, the endpoint for query the system. We just received the user query system, and we take it, we get our embeddings, we call our system, and we get the answers. And I'm going to show you next how it works. So if we come here in services, first of all, I'm going to show you the loader.py. The loader.py is what it is used to ingest files, because we are saying that we're going to manage PDF, we're going to manage docx, and we're going to add doc and also txt. So the only one thing that we do is that we load the file, and when we load the file, we just render it. But now, of course, we have to look at how do we store them. So you have what we call here, also how we have the rag.py. So here it is for the injection that we were talking before. So what is done is that we just call something that is called a splitter, because when we ingest a file, we cannot ingest and store it completely inside our database, because it's going to be huge. Imagine that you have something like more than 2,000 pages in your PDF from all those things. If we store them, it's not going to be easy for us to request them. So it is important to chunk them and to store them by chunk. So we have this splitter that is used here, and we're going to dive in another video. And we split them in chunk, and we have our Chroma database that we do, and then we persist our document. So all these documents are stored and persisted here. And next time that you have a user who wants to answer to the question that, if you remember, we were having here, when the user come and query, and we call the answer question method, that is the method that is called here. We take the question, we take the embeddings, and what we do is that we just get the database, and this is located here. The get Chroma database is just one which initialize the database. We have a collection name that we used to call docs. We have the embeddings. The embeddings is, we can say, the model that's going to be used to encode your data in the vector database, because the vector database doesn't store information just as text or maybe numbers, but they are numbers in space of n dimensions. And for that, it is important to find the right model. So you have different kinds of model. You have model coming from Ollama, you have model coming from Google, and it is important to select the right one. And of course, when you are storing them, and of course when you are getting them, that is why when you see here in the rag.py file, when we use the same embedding that it is important to use the same embedding just for both for query and for build, because if you see here in our query.py, we're going to call the embedding, we just call the get embedding in the embedded file. That is, we're going to use the Ollama embedding here, and we are calling it in every moment. Whether we are going to query it and when we are ingesting it, we are calling the same embedding here. And then in our RAG, what we're going to do is that we have a prompt that we created here. You are help assistant, and use, as you can see, we have the context, and as we were saying before, the context. There is the context. And the context here, if you can see, what is the context? The context is what we have retrieved before, because we have the retriever here, and there is the part, this line 21 is the part where we take the right document here, we just put it here, and we have the question. The question here is the user query. And what we have our internet from, we have the context, we have the question, and we're going to pass it through the LLM. And here we initialize our LLM using Ollama LLM, and we have the LLM model. And the LLM model here, it's what? It is Llama 3.1. You can choose and use the one that you want, but for this example, we just use llama.1, and we can chain those information. So we have the context, we have the question, we have the prompt, and we have the LLM, and we just invoke here and we render the answer. So basically, if you can see, that is the way our system just works. If I have to make a kind of recap, we have the ingest part here to load our file and store them in our database, so that later when we're going to make some kind of request, the system will be able to request it. We have the query file that's going to be used to ask question to our assistant. And then we have the embedded, that file that where we just get the right embedding model. And as I said before, here we just used Ollama, one of the nomic embed text. We have many other things. We have the loader that uses to load files. We have the RAG, where we just ingest file and we answer to the question. And we have vector store that uses to persist and retrieve data from the database, the instance of the database. You have CLI. I also add CLI here because if you want to question the system, you can just use this CLI to be sure that you have answers to a question. It is the same thing as API. You see, you can just add path here if you want to ingest document, and you can use question if you want to ask a question to the system. And if you can see, I like to show that because as you can see, ChromaDB is open source one, and what I really like about it is that when you look at its files, and you can see it here because in the configuration I just say that the directory is going to be .chromadb, and if you come and here in vector store, the way we initialize it is that on line 22 I just say store it in chroma directory. And if you come and see here in chroma SQL, you have all your database here. And of course, because it's SQLite, you can see information, you have the databases, you have the collections, you have any kind of information that's going to help you. But of course, because I didn't just store a lot of things, you can see, but you have docs here that I have ingested some kind of information. So you can see that you can have the database, default database one, you have the collection, you have the metadata, and you have all the information that are going to be used, and you can come sometime and see here what are stored in your database. So here is the applications, the way it is, and of course you're going to have the GitHub links to dive deep inside of that later. And now we're going to make a little demo. So now that our application is working correctly, what we're going to do, I mean working correctly, but I present you to you correctly, I'm going to make some kind of test. So the first test is going to be ingest the file and then ask a question. So first of all, I'm going to ask a question, and after that I'm going to ingest the file. So as you can see here, to launch the server, what you have to do is you become app reload one, and you can find the port that you want. And now what I'm going to do here is just to copy this and come here and to just put it and make /docs. So as you can see here, we have our API ingest and our query ingest file. So we're going to use it to ask some kind of question. As I'm recording the file, we are the 17th of September, and in France there has been a new prime minister that has been appointed. And what I'm going to do is that I'm going to ask a question to our model. I'm going to present you first of all the model that we choose. I just choose to use the Gemma 3 latest model, and for that, as I said before, you just come and select Gemma and you just copy this, and you just have to run it, and it's going to download it on your PC. So what we're going to do now is that I'm going to ask the question, who is the France Prime Minister? And we're going to see what the system is going to access. So what it's doing now is that we received the answer, the query, and the system is just processing it. So we're waiting for the processing, and of course, based on your local machine, you're going to have some kind of answers. And you have I don't know. And that is normal, because when Gemma has been trained, Gemma, first of all, is a model that has been trained for small queries. So it didn't really grasp every internet, everything, and it has been trained far more before. Because as I said, we are the 17th September of 2025, and of course, there are some kind of information that it doesn't know, and even things about prime ministries, it doesn't know it. So what we are going to do is that we will go on Wikipedia, and we are just going to click like France Prime Minister, and we see that it is a person called Sébastien Lecornu, and we're going to click it. We're going to copy all those information here, and we're going to copy the Wikipedia article, and we're going to create a PDF file of that, and that we are going to use. After that, what we are supposed to do is to ingest the file. So to ingest the file, you have this here, and I'm going to just choose what we're going to choose the right file. It's a little bit lagging, and then we can select here French Prime Minister. So I'm going to execute. After executing it will process it, chunk it, and store it in our database. So in the Chroma database, we are going to see new thing. As you can see here, status is okay. And if we come here in Chroma database, and we come in Chroma.SQLite, we look at collections. We have this collection, and there are some kind of document that has been stored. And of course, they are looking at the database, looking at the collection. I don't really remember exactly the way you just look at the content of that, but it's not really important, but you can just use it to come and see what is exactly as I'm coming here. Like you have full text search, you have different things. Yes, full text search, because you see it has chunked it. The prime minister is the whole of a second. It just processed a lot of things. We just chunk it, and we're going to use it later for our query. So if we come again and we ask the same question that we did before, like here, if I come to try it out, who is the prime minister in France, and we just execute it, before we're having I don't know. So if our RAG system just works, we are supposed to have the correct answer, because the system is supposed to go and fetch inside the database relevant information based on the user query. So as you can see, we are still waiting for it, and based on the capacity of your computer, it's going to be quicker or a little bit slower. I'm using a Mac, and a Mac M1, a MacBook Air, and it is quite good. We just have to wait a little bit, and maybe in the video I'm going to speed it a little bit to make sure that you don't wait too much. So we are waiting, we are still waiting for it, and using Gemma 3, we are seeing the processing that is being done. We are just ingest new document, giving him a wider context. We are waiting. Hurrah! I can say. And as you can see, as of the 17th September 2025, the Prime Minister The French Prime Minister is Sébastien Lecornu. And as we can check in Wikipedia, the Prime Minister is Sébastien Lecornu. So we are sure that our application, our RAG system is working. So there is the way to build your RAG. As I said before, first of all, we were not having those informations, but what we did is that we just ingest them. So the system just took those new documents, stored them here. And when the user query just came, we just pick documents that were relevant for us. We just tied them with the personal internet prompt and we send them to the large language model, which render us the right answer now. So congrats to you, you just built an interesting RAG system using LangChain, FastAPI, ChromaDB, and Ollama for the models. Feel free to ask questions, to reach out to me, to have any kind of thing that you can share with the community, and thank you. So that's okay, we just finished our video. I hope that it was good for you. I hope that you enjoy it, and of course you learn a lot. Feel free to comment, feel free to add some kind of old information that can help the community, and I look forward to post more videos to give some more content that's going to be helpful for you guys.